Good day. This is Mrs. Tole from Monthly Private Tutors, as you can see on the paper. Now, today we are going to look at general solution. Now, with the general solution, what you need to master here is that you need to understand that you'll be giving two solutions. And now, with these two solutions, why are you giving two solutions? Because you know that we have got an acute angle, and which falls in the first quadrant, where all sine, cos, and tan are all positive. Then sine will be positive in the second quadrant, tan will be positive in the third quadrant, and cos will be positive in the fourth quadrant. And how do you get the corresponding angle? It's 180 minus theta for sine, then for tan is 180 plus theta, the other angle, then for cos is 360 minus theta. I will help you to understand this. Now, you find that when you are looking at for cos, sine and cos, you find that with your answer, whatever angle that you get, you have theta plus k. So for sine, theta and cos theta, you have plus k 360. Now, we want to understand where is the case coming from. We are now saying the graph itself continue to repeat itself, so it's periodic oscillation, so it's continuing to repeat itself. Like here we know that the period of sine is 360, so it comes again, it starts again to do the same thing here. It's oscillate, we call that oscillation. So here it's going to attain the same values. So you can see that from 30 here, 30 with 90, 390, it goes on to another 720. If you say 720 plus 30, it gives you 750. It's going to give you the same answer. Then 150 again, at 510, it goes on like that. So that's why we say k times k360. So we'll be saying times 2 or times 3 or times 4, goes on like that. Now, then we find that your k can be any number. Now, then for tan, since the period of tan is 180, you find that you'll be saying theta, or whatever angle that you get, plus k 120, 180, sorry, 180. So we're saying it continues to repeat itself until infinity. Okay, that's why I said k 360 or k 180. So because we're not restricted to any value, because if now we say sine, let's say sine 30, we get one half. Sine 150, we still get the same answer. Sine 390, we are in another period now, we're still going to get the same answer. Sine 510, we're still going to get the same answer. So we're saying it continues to repeat itself. So to cut it short, we just say times k3 times k times 360. Okay, now let's go on now. We have different ways to solve a general equation, to solve the equations. We have the ratio equaling value. That's what we're going to do for the first one. Then we also have the ratio equaling the co-ratios. So for example, sine 90 minus theta is going to give you cos theta. So I will show you how it works. Then we'll also be applying also identities and also factorization in solving what we call our equations. Let's first have sine x is equals to 0.42. What do you do now? You know that x is equals to arc sine of 0.42. Now, when you do that, you come to your calculator. This is shift arc sine of 0.42. You get the angle, and when you get the angle, always deal with the two decimal places. Now, here we get 24.83. Okay. Now, so it's 24.83. Let me just put it here. Now, this is the first angle. This is the angle that we have in the first quadrant. What about the second angle? How do we get it? We know that this one is going to be plus k 360. Or we say now 180. The second angle is 180 minus 24.83 plus k 360, because we are now looking at this angle in the second quadrant. So what do? We say it's gonna be 180 minus 24.83. We get 155.17. So it's gonna be 155.17 plus k 360. So always you must know that you must always get two values. You must always get two values because your tan, your sine, your cos, they are positive in two quadrants. The first one is the first quadrant where the acute angle, and the second one is the what is it? Is the what call its quadrant on its own quadrant, like here, second quadrant for sine. Now let's move on to cos here and see what we have here. Now we have got cos 2,7 plus cos x goes to 2,35. What do we do first here? We move 2,7 that side. It's going to be cos x is going to be equals to 2,35 minus 2,7. Then what do we do? What do we find here? 2,35 minus 2,7. We get negative. Let's see what we get here. Cos x is going to be equals to negative 0,35. It becomes interesting now because we are getting a negative. Now, when we have a negative, we have to make sure that, all right, let's say here, x is going to be equals to, we say, that's our answer, sorry. We say arc cos of our answer. What do we get? We get 110, let's say here, arc cos of negative 0,35. What do we get? We get 110,49. Now, understand something here. We are getting negative, so it means that when it's negative, we know that the quadrant will be second and third. That's what we know. The second is second and third because cos is negative in the second and third, and sine in this case we know that it must give us something in the first and second because that's where it's positive. So here we come here and say, all right, now what is our answer? Is 110. So it's going to be 110, 49 plus k 360. Now, when we have this is the first angle, this is the second in the second quadrant. What about how do we get now the angle in the third quadrant? We are going to say, to get the acute angle here, if we say 180 minus 110,49, we just get the acute angle here. This is the acute angle that we are supposed to get if it was positive here. So we are going to say plus 180 because we know that that's how we get the angle in the third quadrant. We add to 180. Then what do we get here? We get 249. So or x is going to be equals to 249,51 plus k 360. That's what we do there. So that's how you get the values there. Okay, let's move on and attempt other questions. So you must always, when you see negative, you must know that we find where it's negative. Where it's negative. Whether it's tan, you know that tan is negative in the second and in the third, in the fourth quadrant. Now let's go on to another question here. This question here, we'll find that it's applying, what is this? The co-ratio. Now, what do we have here? If cos 2x is equal to sine 40. But what do we know? We know that sine cos 90 minus theta is equals to what? Sine theta. Now, what do we have here? We know that we're going to say cos 2x, sorry, is going to give us cos 90 minus 40. So what do we have? Cos 90 minus 40 is going to give us cos 2x is going to be equals to 90 minus 40. 90 minus 40 is 50, cos 50. Now, here's the trick now. We have 2x and 50, it means that they are equal. What do we have now? We're going to say 2x, we equate the values here. 2x is equals to 50 plus k 360. Or the second angle for cos, well, how do you get it? We get it by saying, we're going to say 2x is going to be equals to 360 minus 50 plus k 360. That's the second angle. So from there, we continue to solve. So here, bear in mind here, you don't first solve here saying you divide by 2, then you get 25, then you find the other angle which is equivalent to 25. No, you don't do that. You find the equivalent angle 360 minus whatever you're having here. Okay. Now, what are we going to do? We're going to divide by 2 throughout. That's what the trick here. We divide by throughout, even the 360 as well. Then what do we get here? X is going to be equals to 25 plus K 180. That becomes our final answer. Okay. Then let's check here with this one here. What are we going to do? We're going to get 2x is going to be equals to 360 minus 50. We get 310 plus K 360. Then we divide by 2 throughout. Then we're going to get x is equals to 310. We come here and punch 310 divided by 2. What do we get? We get 155. It's going to be 155 plus K 180. So you must know that for the first time we said it's plus K 360, but now we're dividing throughout so that we can get the actual angle for x. Okay, so this becomes our values. So this becomes your values, your answers, sorry. This becomes your two answers that you must always present. Okay, now let's go on to another scenario again. We are told that sine 2x is equal, sine 2x, 3x plus 30 plus 20 is equal to cos. Again, we do the same thing. We do the same thing here. What do we know? We know that sine 90 minus theta is equals to cos theta. Then it's going to be sine 3x plus 20 is going to be equals to cos, sorry, it's going to be equals to sine, just made a mistake there. Let me just rub here. Okay. Sine 90 minus x minus 10. Can we see that? We are subtracting whatever we're having here. Okay. Then what do we get there? We're going to get sine 90 minus 10. 90 minus 10 is going to give us, it's going to give us 80. So we're going to say 80 minus x. So it means that here, what are we going to get here? Sine 3x plus 20 is going to be equal to sine 80 minus x. And what do? We equate the values because it's sine and sine here. We're going to say 3x plus 20 is going to be equals to 80 minus x plus K 360. Or what do we have? We're going to say, I'm going to have enough space here. I'm going to show you here or there. Then we solve here. Let me just put or here so that we understand before I continue here. Then it's going to be 3x plus 20 is going to be equals to what do we do to get the other angle for sine? 180 minus 80 plus x. So we are saying 180 minus everything here plus K 360. Okay, now what do we do now from there? Let's first solve here. What are we going to do here? We take the 20 that side, we take the x this side. It's going to be 4x is going to be equal to 80 minus 20. We get 60 plus K 360. Then what do we do from there? We divide by 4 throughout. Then what are we going to get there? We're going to get x is going to be equals to 60 divided by 4. What do we get? We get 15 plus, what is 360 divided by 4? We get 90 plus K 90. Then we get, that's our answer there. That's our answer there. So this becomes our first answer. Or we're going to say 180 minus 80, we're going to get 100. Then we take the 20 that side, it's going to be, and x this side is going to be 3 minus x in this case. 3 minus x, we're going to get 2x is going to be equal to 100 plus 20. 100 plus 20 is going to, minus 20, sorry, it's going to be giving us 80 plus K 360. Then we divide by 2 throughout. Then what do? We get x is going to be equal to 40 plus K 180. So those are our two answers there. So you must always give them as as pairs. So you get a pair of answers there. You get a pair of answers there. Then let's move on to where we are applying identities. We are applying identities. Which identity are we going to apply? Tan theta is equals to, sorry, let me just put it down here. Tan theta is equals to sine theta over cos theta. This is the identity that we're going to deal with. Okay, now what do we do here? We're going to say, we're going to divide by cos both sides. We're going to say 8 sine x over cos x is going to give us 3. Then we divide by 8 as well. Then we're going to say this sine here, sine over cos is tan. So tan x is going to give us 3 over 8. Now, what is 3 over 8? X is going to be equals to x tan of 3 over 8. Shift tan, okay, 3 over 8. We get 20,56, 20,56. So it's going to be 20,56. And this is plus K 180. Or what? How do we get the second angle? Or let's put here X is going to be equals to 180. Remember what do we do? 180 plus 20,56 to get the angle in the third quadrant plus K 180. Then what do we get? We're going to say 180 plus 20,56. What do we get? We get 200,56 plus K 180. So this becomes your two answers. So you always have to get pair of answers. Okay. Now let's move on to another question here where you apply factorization. You apply factorization. So here to make your life easier, what you can just do is just say let sine x be equals to x, or maybe let's put y. Let it be y. Okay. Then we're going to say it's going to be 2y squared plus 3y minus 2 is going to give us 0. Then what do? We can open the brackets. We can open the brackets here. So we can this one is the traditional one. Here we find 4y squared. We find the two values that if we add them, we get, if we add them, we get 3y. If we multiply them, we get what called negative 4y squared. So it's going to be plus 4y minus y minus 2 is going to give us 0. Then we have to divide here. This is just factorization, guys. Now what do we get here? We're going to get 2. So some of you know that from here you just open the bracket here and then you find the factors still the same way. Okay, guys. Now here what we're going to do, we're going to take 2y outside, then you're left with y plus 2. Then here we're going to get negative 1 outside, y plus 2 is equals to 0. So what do we have? Go to 2y minus 1, or y plus 2 is going to give us 0. So here is what we're going to have now. We are going to have something like this. Y is going to be equals to negative 1 over 2, or y is going to be equals to negative 2. So now for sine, range of sine and cos, range of sine theta and cos theta is negative 1 less than or equal to theta sine theta less than or equal to 1. So this is what you're talking about here. This is the amplitude that we will also talk about. Amplitude. This amplitude is reaches max. Its maximum value is 1. Minimum value is negative 1. So when we have something like 2, in this case now we're getting 2, negative 2. We know that this one is already out. We can't have arc sine of 2. So we can try to put it here and say arc sine, shift arc sine of negative 2. You find that it will give me error because we're not going to consider that. We're going to consider only the half. So we're going to say sine, therefore sine x is going to be equals to 1 over 2. Then arc sine of 1 over 2, which is going to give you 30. Arc sine of 1 over 2 is going to give us a 30. So it's going to be x is going to be equal to x is going to be equals to 30 plus k 360, or x is going to be equals to, what do we do, 180 minus 30, we get 150, is going to be equals to 150 plus k 360. Okay, these are your two values that you have to find here. Okay, now, so these ones here, I'm just going to give you a hint how you're supposed to go about it. Now here, for this one here, we are given that sine squared x minus 2 cos squared x minus sine x is going to give you 3. So you know the identity that says sine squared x plus cos squared x is going to give you 1. This identity, you deal with it. So this one here, you're going to substitute for cos, because you want everything to be in sine, because you've got two signs here. So you're going to say cos squared x is going to be equals to 1 minus sine squared x. Okay, then you substitute here. So it's going to be sine squared x minus, in the bracket, 1 minus sine squared x minus sine x is equal to 0. Then what do we get here? We're going to get positive here, sine squared x minus 1. Then we get plus sine squared x minus sine x is equal to 0. Then we have something like this, 2 sine squared x minus sine x minus 1 is going to give you 0. This is something that you can factorize. Okay, this is something that you can factorize and do what you have done that side. Now again here, what must you do for in this case here? You find that here you've got cos, and you can't turn this one into sine, because you're still going to deal with the cos here, and it's going to give you a problem. What do you do now? You factor out what is it, cos. You say what is it, cos x, and you are left with 3 sine x minus 4 cos x, is then this is going to give you 0. So either cos x is equal to 0, or this one here is going to be equal to 0. When you have this one here, what do you deal with? You deal with the identity which says tan theta is equals to sine theta over cos theta, which we have done on top here. I'll just show you here, which we have done here. Okay, then or cos x is equal to 0. When you say cos equals to 0, you're also going to get what you call your answers there. Okay, so I hope you guys understand the general solution, how you're supposed to do the general solution. Okay, until next time, guys, thank you so much for listening.